Okay, let's do some math for fun. Here I have two double summations for you guys. Yes, two double summations, not two double integrals. But don't worry, because I will give you guys a double integral right here. So just wait for it. Anyway, as we can see, we have 1 over 2 to the m plus n's power in both of them. But for the first one, we have the sum as n goes from 1 to infinity, and then m goes from 1 to infinity. However, here we have the sum as n goes from 1 to m, and then m goes from 1 to infinity. And keep in mind, whenever we are doing a double summation, we do this part first. This technically like an invisible parentheses, likewise for this, right? You do the inside, get the result, and then you look at what we should do for the outside part, right? Anyway, be sure you guys pause the video and try them carefully. Okay, hopefully you guys all have a chance to try it. Let's do this one first. This is not that bad at all. Let me write this down again. The sum as m goes from 1 to infinity. And for this, I will put this down in red. The sum as n goes from 1 to infinity. And for this right here, of course, we can write this down as 1 over 2 to the n times 1 over 2 to the n, because this is 2 to the n plus n's power. We can just break it apart like this. And this right here, I will like to emphasize with the parentheses, right? That's what I talked about earlier. We have the parentheses around it. Now, take a look right here. We're supposed to do the sum as n goes from 1 to infinity. Well, we have 1 over 2 to the n. This is just like a constant multiple in the n world. We can actually just put it to the front of the summation and then just handle the red part first. So we will do that. With that said, we will have the sum as m goes from 1 to infinity, and then 1 over 2 to the n, and then we multiply this by the sum as n goes from 1 to infinity, and this is 1 over 2 to the n, like this. Very nice. And now, as we can see, this right here, 1 over 2 to the n, it has no m being involved, likewise for the summation right here as well. This is just going to give us a number because this is a convergent geometric cookie series, right? So we just have an answer for that. Multiply by 1 over 2 to the m. Just get an answer. And then, just do the sum. But the good thing is that, as I said, this and that, this and the m has nothing to do with each other. The idea is you can actually just look at this as a product of two summations. So I can look at this as the sum as m goes from 1 to infinity, and then 1 over 2 to the m times the sum as n goes from 1 to infinity, and this is 1 over 2 to the n. And of course, you can just handle them nicely. They are exactly the same anyway. All right, anyway. Remember, for geometric cookie series, you put down the first term divided by 1 minus the common ratio. First term right here, we just put a 1 in here, we get 1/2. Divided by 1 minus the common ratio is just 1 over 2 right here, right? And for this one, same thing. So we multiply by 1/2, and we have 1 minus 1/2. And guess what? This is 1, this is 1. 1 times 1, we get 1. But let me put down this one in black and then this one in red, and we have another 1 right here for the final answer. Anyway, that's it. The beauty is the summation, this and that, they really have nothing to do with each other. And when they don't have anything to do with each other, you can actually just multiply the inside together and create a double summation very nicely. For this one, n goes from 1 to m. So unfortunately, we have to kind of keep it in that order, huh? Let's emphasize with the parentheses like this. Let's see. Yes, you can break this apart like that. So if you want to do that, yes, let's just put that down. We have m is equal to 1 to infinity. And we have the sum as n goes from 1 to m. And this is 1 over 2 to the m times 1 over 2 to the n. Okay, sure. Yes, it's actually possible to handle the inside, get the result, and then you run through the summation as m goes from 1 to infinity. It's possible, but I'm not going to do it. You can try that. I will leave this to you guys, right? Because I would like to show you guys how to change the order of a double summation. Really cool. By the way, we can change the order of summation because this is an absolute convergent because this is, all positive terms, so any converges. That's very nice. Anyway, here is the deal. I would like to write down the answer for you guys first to see if you guys buy it or not. Well, let's look at the inside, and we'll color this in red. N goes from 1 to m, right? So the inside, you're supposed to do this first, right? Well, now I will put it outside first. So I will write this down as the sum, and I would like to have n right here. When we change the order of summations in this situation, what we'll get is n goes from 1 to infinity, and then this right here inside, it will be this. The sum as m goes from n to infinity. This is how you change the order for that. I will give you guys a quick explanation on why this is true by using some, what's that called? Inequalities. All right, anyway, so if you guys look at the m part right here, so we have n goes from 1 to m, right? So I will just write this down right here for you guys right here, okay? If you look at n, well, n goes from 1 to m. So we can put it down this way, right? N goes from 1 to m. Well, m goes from 1 to infinity. So you can look at m right here, goes from 1 up to infinity. So I'll put down like this. Well, you can never be equal to infinity. I don't know if you want to include infinity. Just put down infinity, put down equal sign. Doesn't really matter, okay? All right, so as you can see, this is pretty much the inequality. N goes from 1 to m, and m goes from 1 to infinity, right? Well, what's happening is that we can look at the m first. If you look at the m first, which is the inside portion, then you're looking at this part, which is saying m goes from n to infinity, which is this to that, and then you look at the m part, which is 1 to infinity, and you're done. Yeah, that's pretty much the quick explanation for that. And now, as I promised it, I will show you guys how to change order of a double integral. So here we go. Suppose we are integrating, and let's say we have a function f of x, y like this. And let's do it with respect to x first. And as we can see, I'm using the ref for the inside first. And I will put x equals 1. Well, I want to stop at m earlier, right? N goes from 1 to m. So for the integral version, I will just say x goes from 1 to x equals y. Okay? So this is similar idea with that. And then, of course, I need the integral on outside, right? For that summation, that idea. And m goes from 1 to infinity. So in that case here, I will put down y equals 1 to infinity. Okay? All right. Don't forget the dy. Now, how can we change the order of this double integral though? Well, let's see. Let's draw some pictures. Let's see. Of course, we have the x and y plane right here. Let's look at inside out, of course. X goes from 1 to y. What that means is, of course, this is when x is equal to 1. It's just a vertical line. And when we have x is equal to y, of course, this is just that diagonal right here. This is x is equal to y. So we have this to that. And it says y goes from 1 to infinity. So let's say this is 1. So we have to go from here and then all the way up to infinity. So we want to talk about all this part right here to infinity. Now, again, this is step 1, step 2, step 3, step 4. Well, we are going to see how to change the order right here. Let's see, I want to integrate this guy with respect to y first. In that case, I will have to ask myself y goes from what to what then? Well, you see, the base, right, the bottom, I should say, the bottom of the y, it's actually right here, right? And then go up to infinity. So the first step that I have to do is draw y is equal to x. So I'll put this down right here. This is y is equal to x. So you start at x. And then you go up to infinity. So just keep that in mind. You want to have this portion up. Okay, you want to have this portion up. So I will just kind of just put it down like this for now. And technically, if you just have y is equal to x, it's like this part, right? But let's see. In order for us to just get this part, of course, we will just have to have the integral, and this is the dx. x has to go from 1, so that we can cut this right here. This is x is equal to 1. And we just want to go 1 to infinity, like that part. So, as you can see, when x goes from 1 to y and then y goes from 1 to infinity, it's the same as y goes from x to infinity and then x goes from 1 to infinity. And that's the same idea right here. So, that's pretty cool. But of course, we still have to finish this right here. And perhaps sometimes this is nicer because we like to deal with infinite geometry series. I think that's a better formula, right? Anyway, for this part though, again, we will have to just do this. So we have this inside. I will look at this part, which is 1 over, let me just write it down, 1 over 2 to the n. And I want to put this part in black and then this part in red. 1 over 2 to the n. Well, I will have to take off this because in the m world, this is like a constant multiple. But let me actually write it down again like this, okay? So we have the sum as n goes from 1 to infinity. Parentheses, I will put this in the front. 1 over 2 to the nth power. And we will have the sum as m goes from n to infinity. And then 1 over 2 to the n, like that. Now this time, I will actually just work this inside out because after the result right here, we will still have some n left because m goes from n to infinity, all right? And I need more space, so much better. All right, so now we will see this right here. It's the sum as n goes from 1 to infinity. Keep that, which is 1 over 2 to the n. This right here, it's an infinite geometric cookie series. But the first term is when you put n in here. So we actually have 1 over 2 to the n, and then divided by 1 minus the common ratio is again 1/2. So I put down 1/2 right here. And then of course we will just work this out. And as we can see, we have 1 over 2 to the n times 1 over 2 to the n. That will give us 1 over 4 to the n. So let me put that down right here for you guys. I will still write the summation in red. N goes from 1 to infinity. But I think for this one, I will just put this down in blue, right? So this times that is 1 over 4 to the n, like this. And don't forget, we still have to do 1 over, right? This is 1 over 1 minus 1/2, which is 1/2 here. 1 over 1 over 2 is just 2. So we multiply by 2. And let me just put the 2 all the way in the front. That's times 2. Put the 2 in the front. Anyway, for this guy, we will have the following. This is 2. Okay, I'll do this in blue. Put a 1 here for the first term. So we have 1 over 4 divided by 1 minus the common ratio here is 1 over 4. So we have this part right here. And now let's see if I can do fractions. This is 1/2 on the top, yeah, 1/2 on the top over, this is 3 over 4 on the bottom. Yeah, and then this is 1/2 times 4 over 3. So all in all, we have 2/3. So I'm going to erase this so that you guys don't see anymore. But anyway, when you do this times that, you get 2/3 for the answer. Wow, so much cooler, huh? So it seems like we are missing a third if we just go from n is equal to 1 to n instead of n goes from 1 to infinity. Okay? But anyway, hopefully you guys all like this right here, and leave a comment down below if you guys have any questions. Thank you guys so much for watching, and as always, that's it.